Welcome to a journey of cosmic exploration, where we venture deep into the origins of our universe and challenge what we thought we knew about the Big Bang. Today, we unravel the classic narrative of the Big Bang Theory and take a closer look at an alternative perspective offered by visionary scientist Richard Lieu. His theory, centered on the concept of temporal singularities, invites us to rethink the very nature of time and space as we have long understood them. For decades, the Big Bang Theory has stood as the cornerstone of modern cosmology. According to this widely accepted model, the universe began approximately 13.8 billion years ago from an extremely hot, dense state. From this primordial explosion, every star, planet, and galaxy emerged, propelled outward in an ever-expanding cosmos. The elegance of the Big Bang Theory rests in its simplicity and the compelling evidence that supports it, from the discovery of the cosmic microwave background radiation, a faint afterglow from the universe's fiery birth, to the observed expansion of galaxies moving away from one another. However, science thrives on questioning, and here is where alternative ideas enter the stage. Richard Lieu challenges the conventional wisdom with his intriguing hypothesis centered around temporal singularities. Unlike the traditional view, which posits a clear beginning in time, Lieu's model prompts us to consider what might happen if time, rather than beginning with a singular explosive moment, is subject to moments of extreme density or distortion that intermittently birth new cosmic phenomena. Imagine time not as a smooth, continuous line, but as a tapestry woven with threads of intense, concentrated moments, singularities where the fabric of time itself is stretched and contorted. Lieu suggests that these temporal singularities could offer glimpses into a process of universe formation that operates differently from what we have accepted so far. In his view, rather than a single explosive event, the universe might be shaped by recurring episodes of transformation, events so powerful that they redefine our understanding of beginnings and endings. This idea, though at first it may seem abstract, carries profound implications for our understanding of cosmology. Consider the mysteries of dark matter and dark energy, enigmatic forces that together make up most of the universe's mass energy content, yet remain invisible and elusive. The classic Big Bang model accounts for many observed phenomena, but leaves some questions unanswered about the true nature of these dark components. Lieu's innovative approach, with its focus on temporal singularities, opens up a new arena in theoretical physics, where these unseen elements could be re-examined under a different light. Could these singularities be the missing piece that explains how dark matter clusters together, or how dark energy influences the cosmic expansion? Furthermore, embracing such alternative theories highlights an essential aspect of scientific inquiry: the readiness to remain open-minded and re-examine the foundations of established knowledge. Richard Lieu's work invites scientists, students, and curious minds alike to peer into the depths of our cosmos with fresh eyes. His theories implore us to consider that our universe might be far more complex and dynamic than our current models suggest. They remind us that science is not a static collection of facts, but rather an evolving process of discovery, constantly refined by new ideas and observations. Let us take a moment to appreciate the dialogue between tradition and innovation here. On one hand, the Big Bang Theory has provided a robust framework, supported by numerous observations and decades of research. Its simplicity and explanatory power have made it a triumph of human ingenuity. On the other hand, theories like Lieu's provoke us to ask, what if the traditional narrative is incomplete? What if the universe is not just the result of a sudden explosive event, but a complex beam of interwoven moments, where singularities in time give birth to new cosmic phenomena? The conflict between these interpretations fuels some of the most exciting debates in cosmology. It is this intellectual tension between a tried-and-true framework and the bold vision of an alternative that drives science forward. By challenging established ideas, researchers like Richard Lieu infuse the field with a sense of wonder and possibility. They encourage us not only to study the stars and the galaxies, but also to question the very nature of time and existence. As we explore these theories, it becomes clear that every scientific model is, in many ways, a snapshot of our current understanding. Today, the Big Bang Theory reigns as our best scientific explanation, Yet theories like Lieu's remind us that the universe might still hold secrets waiting to be uncovered. The pursuit of truth in cosmology is a continuous journey, a dialogue between what we observe, what we understand, and what might still be out there, just beyond the reach of our current theories. In considering temporal singularities, we confront one of the most fundamental aspects of existence, time itself. Our everyday experience treats time as an ever-moving stream, an inexorable march from past to future. But what if, at critical moments, time behaves in unexpected ways, bending and warping in a manner that could catalyze the formation of cosmic structures? In Richard Lieu's proposal, these singularities could serve as catalysts, sparking events that reshape the universe in both subtle and dramatic ways. This line of inquiry does more than challenge established thought. It ignites a broader conversation about the nature of our cosmos. It encourages us to embrace complexity, to delve into the less explained, and to remain ever curious about the universe we inhabit. Whether you are a seasoned astrophysicist or a curious learner with a passion for the mysteries of space, the discussion about temporal singularities is a reminder that every theory, no matter how widely accepted, remains open to reinterpretation in the light of new evidence. As we reach the end of our exploration, it is important to reflect on the beauty of scientific discovery. Each theory is a stepping stone towards a deeper understanding of the universe. The Big Bang Theory has illuminated the path for generations of scientists, while pioneering alternatives like those of Richard Lieu push us to explore further, questioning the status quo and seeking truth in every corner of the cosmos. In concluding our exploration, we are left with a profound message. The universe is vast, and our journey to comprehend it is far from over. By challenging established theories and seeking new perspectives, whether through examining the explosive birth of the cosmos or delving into the enigmatic dynamics of temporal singularities, we embrace the spirit of inquiry that has always defined scientific progress. The dialogue between tradition and innovation sparks a quest for knowledge, ensuring that our understanding of the universe will continue to evolve, expand, and inspire for generations to come.